Alright guys, this is Miss Murphy back again with the second part of 5.1, which is the power rule. Now, first off, the power rule just simply means is that you're raising a power to another power. Alright, so for example, if you had 2 cubed and then you raise it to the fourth power, this is the same thing as 2 cubed times 2 cubed times 2 cubed times 2 cubed. So in other words, if you think about it, 2 cubed is 8. So this is 8 times 8 times 8 times 8. So that's the same thing as 8 to the fourth. All right. And then if you put that in your calculator, 8 to the fourth would be 4096. All right. P squared would just be p squared multiplied to itself 5 times, which we know if we add those exponents, 2 plus 2 is 4, plus another 2 is 6, 8, and 10. This is the same thing as p to the 10th. And then lastly, x to the m is the same thing as x to the m times x to the m. So that'd be equal to the x to the m plus m, which they are like terms. So this would be x to the 2m. So essentially, all you're doing is that you're multiplying the powers, or the exponents, however you want to put it, of same base, or to all the bases. So, and this is to all bases. So for this power rule, x to the m raised to the power of n is the same thing as x to the m times n. You would just distribute the n to the m. So let's look at some other examples. So if I rewrote this in standard form, this is the same thing as 2 cubed x times 2 cubed x, which if we multiply them together, that would give me 2 to the 6 x squared, which if we just distributed the 2 to the exponent of 1 and 3, multiply them together, it would still give us 2 to the 6x squared. So if I evaluate the 2 to the 6, it'll be 30, no, not 32. It'll be 64x squared. Do the same thing for this one. So this would be 8n squared p times 8n squared p times 8n squared p. So 3 8s together would be 8 cubed. Add the exponents, so that would be n to the 6. And then p would be n cubed. Same thing as if you distributed the 3 to all of the bases, including the 8. The 8, even though it's technically a coefficient, if you're raising it to a power, you have to raise the coefficient to the correct power as well. So then this would be 512 n to 6 p cubed. So this last one, all right, 2 ways you can go about this. You can go, well, let's just expand it. So this would be 3x over 4x squared times 3x over 4x squared. Which, remember, if you are multiplying fractions, you multiply straight across. This would be 9x squared over 16x to the fourth. And remember, we can now do the quotient rule, so we can subtract these. So 4 minus 2 is 2. And since this is the bigger exponent, we'll put in the denominator. So this would be 9 over 16x squared. So power of a product, it would be ab to the m power, multiply it to an exponent of 1. This would be a to the m times b to the m. Same thing with the quotient. All you would do is multiply. So this will be a to the m over b to the m. And then you do any other simplification you need. So I usually recommend doing power rule first, just because it takes care of a lot of things, and then do your multiplicative and division rules or quotient rules. So let's do some examples. So let's do number 1. Very easy. All you got to do is just multiply that 4 to the 3, get y to the 12th. Same thing with number 2, multiply the 2 to the 3, get 10 to the 5th, which we all know 10 to the 5th is 100,000. Now, number 3 is a little bit different because there's only one power rule, and I recommend doing that first. All right, so if you do 2 times 5, that's 10. So this would be b squared times 2b cubed times b to the 10th. So we bring down the 2 because it's only be multiplied to coefficients of 1, and then we add the exponents. So 2 plus 3 plus 10, that'll be b to the 15th. Now, for number 4, be careful because both of these are considered bases. So I got to multiply the 2 to both of those bases, including the 5. So both of them are going to be multiplied 2 by 1. So this will be 5 squared x squared, so 25x squared. Then we got number 8. So with number 8, this cube is only being applied to what's in the parentheses. So I'm doing 2 times negative 3 cubed a to the 6. So remember, if you cube a negative, it's going to remain negative. So this would be 2 times negative 27 a to the 6. So this would be negative 54 a to the 6. All right, we'll do 2 more. So number 11. All right, you multiply this 5 to every single base in here, so even to the numerical bases. So this would be 3 to the 5th times x to the 10th over 2 to the 5th times y to the 10th. And then we just simplify where needed. So 3 to the 5th is 243. X to the 10th all over. 2 to the 5th is 32. Y to the 10th. And they don't really have anything in common that I can tell. So we'll keep it like that. And then the last one we'll do is number 14. So with number 14, again, you want to do that power rule first before you do any other form of simplifying. So I'm going to multiply the 3 to both bases. So this will be 20x cubed all over 5 cubed x to the 6. So if I simplify the 5 cubed, that'll be 20x cubed over 125 x to the 6. I'm going to simplify the 20 over 125. So if I do that, I'm going to divide both the top and the bottom by 5. So that would give me 4x cubed over 25 x to the 6. And then I'll simplify the x cubed x to the 6. So this will be 6 minus 3 is 3, and it'll stay in the denominator. So this will be 4 over 25 x cubed. And that's it for 5.1. So if you have any questions, please feel free to reach out. And remember, you do have that delta math for 5.1. It is a combination of 5.1 and 5.2. So you really only need to do the parts for 5.1, and you can do the 5.2 part later. All right. Have a great rest of y'all's day.